Good morning everyone. My name is Saket Pandey. Currently I am pursuing MTech in Structural Engineering from IST Sipur. Today I will teach you topic mechanical properties of solid. The first point which I tell you about is what is rigid body. The rigid body is a body in which there is no change in shape and size on the application of the external force. So we understand what is rigid body. Let's understand more clearly with the help of an example. Let us consider a body which is fixed at its one end and free at the other end. And if we apply a force of magnitude F, then there will be no change in the length of this body. So for this rigid body, delta L equal to 0, where delta L is the change in the length of the body. So we understand what is rigid body. Let's move on to what is deformable. A deformable body is the one in which there will be a change in shape and size on the application of the external force. In the previous case, we study about rigid body. Rigid body is an ideal case. Practically, rigid body is not possible. So, deformable body is the case which exists in the real life. So, we can write it as the deformable body is a type of body in which there is a change in shape and size of the body on the application of the external force. We can see this external force as the deforming force. Let's clearly understand the concept of deformable body through an example or through a figure. Let's draw it. So this is a figure of a deformable body which is fixed at this end and force is applied at this end, and its initial length is L. And if we apply the force, and after the application of force, delta is its change in length, which is not equal to 0. So this is the biggest difference between the rigid body and deformable body. In rigid body, delta L equal to 0, and in deformable body, delta L is not equal to 0. So we understand what is rigid body and deformable body. Let's go to the new slide. So the next topic which will be study is elasticity. What exactly is elasticity? It is the property of the body to regain its original shape and size on the after the removal of the external force. For example, if there is a force acting on a body due to which its shape and size changes, but after the removal of the load, if it gets back to its original shape and size, then that property by which it is getting back to its original shape and size, this is elasticity. So we understand what is elasticity. So this elasticity property is valid within certain limit of the force. For example, let's consider a rod. If if we apply the force within its elastic limit, then the rod will regain its shape after the removal of that load. So elastic limit is that limit in which if we apply the force, it regains its original shape after the application of the load. This is the first definition through which we can understand what is elasticity. There is another one definition through which we can clearly understand what is elasticity. So we can write it as the tendency of the body to resist any change in shape and size of the body. So we understand the another definition of the elasticity also. Now we will understand one very important question: which is more elastic, steel or rubber? So we differentiate between steel and rubber on the basis of elasticity, which is more elastic. Steel. If for a given steel, if we apply a certain force, then deformation in that steel will be less as compared to the rubber. If the same force is applied in the rubber, the deformation will be large as compared to the steel. So we can say that its change in length in steel is less as compared to that of rubber. So we can write it as, so we write it as delta L steel is less than delta L rubber, where L is the change in the length of rubber and steel, and where L is the length which is same in both steel and rubber, and a F force is applied which is also same in steel and rubber. Then we know that there will be a less change in length as in steel as compared to rubber. So now we can understand one another thing through which we can clearly understand why steel is more elastic than rubber. So modulus of elasticity will help us to understand why steel is more elastic as compared to rubber. So we write modulus of elasticity as modulus of elasticity is the ratio of the stress to strain on a body. So we can write modulus of elasticity as E is equal to sigma upon epsilon, where epsilon is the strain acting on the body and sigma is the stress in it. Okay, we can understand sigma stress as sigma equal to resisting force upon per unit area. Okay, and we can more clearly understand what is stress with the help of a drawing. For example, let's take a rod which is fixed at one end and a external force Fe is acting at the other end. Due to this Fe, there will be some resisting force developed inside it which oppose this external force, and that force is Fr. Then stress is the resisting force per unit area, which is denoted by sigma, and its unit is Newton per meter square or Pascal. We can understand other units of stress in fur- further slides. So we understand after this what is strain. Strain is change in length upon original length. This change in length, at the place of change in length, there can be change in width also if the force is applied in that direction, or the force is if force is not applied in direction of its width, then also there will be some change in width, which we'll understand later through with the help of Poisson's ratio. So for for now we have to study who is more elastic. So we we can say that in steel the strain will be less as compared to that of rubber. So its modulus of elasticity will be higher as compared to rubber. So we go back to the previous slides and write this as modulus of elasticity of steel is higher than modulus of elasticity of rubber. So, and those material whose modulus of elasticity is higher are considered as more elastic as compared to those which have lesser modulus of elasticity. Okay, so steel is more elastic as compared to rubber. Rubber. Okay. So the other point which we'll study is type of stress. The stress are of two types. The first is the longitudinal stress and the other one is shearing stress, which is also called as tangential stress. We will start with longitudinal stress. So longitudinal stress is of two types. The first is the tensile stress and the other one is the compressive stress. These tensile and compressive stress are differentiated on the basis of the force if it try to extend the length of the body or it try to compress it or reduce its length. For let's start with tensile stress. So tensile stress is that type of stress which occurs in a body when external force try to stretch it. It means try to increase its length or pull the body from the both side. For let's understand it with a drawing. So this is a body which is exerted by a force which try to stretch it from its both side. Then resisting force will try to resist that stretching. So resisting force will act in a inward direction. So we can draw this resistive force is at it try to resist that external force, so it will act in a inward direction since external force acting in the outward direction. So this is a tensile force. So after this, we will study what is compressive compressive stress. So compressive stress is a type of stress which occurs in a body when external force try to reduce its length or try to compress it, try to push it from its both side. So we can understand it with the help of a drawing. Suppose this is a body which is compressed both side by a external force Fe, then resisting force will resist this external force, so it will act in a outward direction. So we can make this resisting force like this. So external force is acting in the inward direction and resisting force is acting in the outward direction. So this type of stress in which this resisting force try to the external force try to compress the body. This type of stress developed in this type of body is the compressive stress. So here we have to write what will be the formula of the tensile stress. Here in this case, sigma is equal to Fr by Fr by A, that is resisting force per unit area. And for 99% of the case, we know that resisting force Fr is equal to Fa. So we can write it as like this, and in this case also sigma is equal to Fr by A, where Fr is equal to Fe 99% of the case. So we understand what is the difference between a tensile stress and a compressive stress, and both is the part of the longitudinal stress. And the other stress after longitudinal stress is shearing stress, which is also called tangential stress. We will study this in the next slide. So what is shearing stress? First, we will understand the concept of the shearing stress with the by understanding the word shearing. What exactly is shearing? Shearing is the sliding of planes. When one plane try to slides over one another, then shearing will be. Then this process is called shearing. Like when we are walking on a road, or when we are trying to cut a paper with the help of a knife, then shearing is occurring because one plane is sliding over the another plane like this. So this is called shearing, and shearing stress is a type of stress when one force is moving parallel to the body. Okay, we understand with this with by drawing a figure like this. So this is a body which is fixed at its bottom end, and if we apply the force at the top face like this, then due to this force, the shape of the body will change. And one important thing about shearing stress is that it changes the shape of the body, change the shape of the body, shape of body. And so this is the body whose shape gets changes by applying the a force on the top face, which and the body is fixed at the bottom face. Then there will be change in shape of the body. This is theta, and initially the body is A, B, C, and D, and after changing the shape, it becomes A dash, B dash, C dash, D dash. So this is shearing stress. Shearing example of shearing stress we have already understand, like when we are walking on a road, when we are trying to stop anything, like starting and stopping of a car, and when we are trying to cut a paper with the help of a knife. And after this, will we understand the other type of the stress, which is volumetric stress. So we will write volumetric stress. So volumetric stress is a type of stress which acts on the entire volume of the body. It's try to change the size of the body. So we can understand this with the help of a figure. Suppose this is a body which is immersed in, let's take it, in water, then the water will exert pressure all over the volume of the body and try to reduce its size. So we can write it as, so this is the force P which is acting all over the volume of the body, due to which its size is reducing. Then here the stress developed in this case is volumetric stress. So we clearly understand the all type of the stresses which can act on a body.